This is a lesson specifically on circular questions. So when you have a question that is a Ferris wheel or a tire or a clock or something that's round, this is focusing especially on those questions. Example 1, a bike wheel has a diameter of 70 centimeters and the rider completes one cycle in 0.8 seconds. What is the speed of the bike? Okay, here's our important information. We've got a diameter and we've got one cycle, so we're talking about the period there in 0.8 seconds, and we're looking for the speed of the bike. So here are two really important formulas when we're working, well, the first one is specifically for circles. Circumference is pi times diameter, and because this question's about speed, we need to remember that speed is distance divided by time. Okay, so let's take a look at what we've got here. Let's start with that speed formula. Speed is distance divided by time. Okay, so distance divided by time. But we don't know, well, we're looking for the speed. We don't know that. We don't know the speed. What's the distance? And what's the time? Well, we know that the time, one cycle is 0.8 seconds. So let's say we're talking about one cycle here. So we can put a 0.8 there. I need to know one more thing. I can't leave two unknowns. What I do know is a way to figure out the distance. Because if we're talking about the distance, in terms of a circle, the distance is the circumference. So if you imagine taking this tire right here and cutting it. If I cut it, say I cut it somewhere, I cut it right here. And I laid it out flat. So I took this and I pulled it out and laid it out flat. So I've got, there's that line, and here's the tire all laid out flat from there to there. That's the circumference, that's this length around here. So the circumference here is now the distance traveled. So the distance traveled, if there was something on the tire at this spot, like a piece of, a tack or something in there, the distance the tack travels is the same as the circumference, this distance that the tack would have traveled is the circumference. Let me erase that, it's kind of messy. So the distance here, and for distance, that's the same as the circumference. I'm going to change that to a C there. And the circumference is pi times the diameter. And the diameter, they tell us in the question, is 70 centimeters divided by 0.8. So you get your calculator out here and you do the math, and we will have an answer there for speed. Let's take 2 decimal places. So we have 274.89, and let's put some units on that. The distance we measured was in centimeters, right? Centimeters. And the time was in seconds. But the question says meters per second right here. So we've got to convert centimeters to meters. So make sure you are answering the question. So to do that, we need to divide by 100 and we get 2.75 meters per second. Whenever we have a word problem, we need a word answer. So let's put a sentence here. Therefore, the bike's speed is 2.75 meters per second. Okay, that one is pretty straightforward compared to example 2. Example 2. The tires on a car each have a radius of 40 centimeters. Okay, we know that's going to be important. There's a spot of paint on one tire and wet paint on the road, half a kilometer behind the car. Right away I see I've got kilometers, centimeters, so I'm going to have to convert like I did in my last one. I'm going to have to either use centimeters or kilometers. What we're looking for is the height of the paint spot. So I want you to think back to our last lesson. I told you that it's sometimes really helpful to draw a picture, not just a graph. So if I drew a tire, a car here, and I have a car tire, and it's got a radius of 40 centimeters, that means its diameter all the way across is 80 centimeters. And I've got a spot of paint on it. So let me put a spot of paint on it somewhere. So it picks up the paint at the bottom, right? It drives through the paint, so it's obviously picking up the paint down here at the bottom somewhere. And it drives for a while, so it's spinning around and it's driving off in this direction, and the tire is spinning as it drives. And the paint is moving its height above the ground. So let me just put the ground on here. Let's say the ground is this, the ground is this line here, or the road, it's driving along that road there. And the paint is, of course, moving up around the circle as it goes. And its height is changing, right? Sometimes it's at the maximum, sometimes it's at the minimum, but it's all the way around. The question is asking for the height of the paint spot half a kilometer later. So it starts off at the bottom of the tire, and then after a half a kilometer, let's draw another little image of the tire. Let's just do this one kind of dotted to show this is where the tire is going to end up. Where is the paint now? So we don't know where the paint is. It could be up here at the top, sort of. I don't know. The paint is somewhere on the tire. We're trying to find out that height. That vertical distance is the height. So think about this for a minute. How are we going to do this? We have some information from up here. We have these formulas. The speed doesn't really look to be important. I don't think we're going to need the speed formula. We might need the circumference, we might not. But let's figure out the circumference anyway. Circumference equals pi times diameter. So the circumference of this tire is pi times 80. And I can leave that as pi times 80, or I can use the pi button on my calculator. Rather than typing in 3.14, I would use the pi button on my calculator, but let's say that's about 251.3. What does that mean? What is that number that we just found? Yeah, it's a circumference, but what does it mean with this question? The question didn't say find the circumference of the tire. So what it means is, remember, if we took a tire and we cut it and we laid it out straight, that would be its length or its distance. So that's one full cycle. That's what we have here. We have one full rotation of that spot of paint or whatever. One full rotation is 251.3 centimeters. So we can also call that one period. So one cycle of this tire spinning around is 251.3 centimeters. That's a horizontal distance. So the next thing we need to think about is if the tire's rotation or its cycle is 251.3 centimeters, then in half a kilometer, how many cycles were there? How many times did it rotate? How many times did this paint spot get right down to the bottom again? How many rotations did it go through as it was going around and around and around in half a kilometer? How many cycles went through? Now here we have to look at our units, because I said half a kilometer, but I also said 251.3 centimeters. So let's put half a kilometer into centimeters. Half a kilometer into centimeters, what is that? So half a kilometer, written like that, how many times do I have to move the decimal? I'm going to have to move it, I'm going to have to, for half a kilometer, multiply by 1,000 for meters, and then multiply by 100 for centimeters, and we get 50,000 centimeters. So now we've got everything in centimeters, and that's a little easier than converting and working with small decimals, like moving the centimeter to a kilometer. Then that would give us a lot of zeros and placeholders. So let's keep it like this. Okay, back to what I was talking about. How many full cycles around how many periods have we had in half a kilometer? To figure that out, I've got to do 50,000 divided by 251.3. So that gives us about 198.965 rotations. In a half kilometer. So that tire has gone around almost 199 times, right? It's gone through 190. So the 198 part doesn't really matter. This paint spot that's at the bottom has come back down 1 rotation, 2 rotations, 3 rotations. So 198 times and it's back at the bottom again. So we've got 198 full rotations, but we've got 0.965 of another, and that's the important piece. I need to know that 0.965 of a rotation. Where is that paint spot now? It's almost rotated all the way back around again, right? If it were 199 rotations, then it would be, the paint spot would be right back at the bottom. That's almost down there. So I'm looking, so let's switch colors here. 0.965 of a rotation. So that's what we've got to deal with. The first 198, that just takes the paint spot and leaves it right at the bottom, so we can kind of ignore that. Those are full rotations. It's this extra piece at the end. 0.956 of a rotation. Where's the paint spot now? Where is the paint spot? And I want to point out there's more than one way to do this question that we're doing right now, and some of those will come up in your homework. So if you were thinking of another method, it quite likely would have worked. I'm just going to go over this one today. So where will the paint spot be? After almost a full rotation, 0.965 of a rotation. So how am I going to use that? The answer is not 0.965 centimeters above the ground. That's not what that means. We're talking about this portion of a rotation. So that's 0.965. Remember that in math, of is multiply of a rotation, and one rotation, looking back up here, is 253.1 centimeters. That's around the outside of the tire. So what is that equal to? Oh, and I switched my numbers there, sorry. I gotta change my 53.1 to 51.3. 51.3. I multiply these two numbers together, 242.5. Okay, what does that mean? Well, that's an answer in centimeters, and that is the distance it has traveled. So it has gone around, so it's going around this 242.5 centimeters around. All the way around would be 251.3 centimeters. So it's gone around, so it's going kind of rotating around. The paint is going around and around and around. 242.5 centimeters. We'll put that around the tire, or around the circumference. Well, so far we haven't really used any trigonometry, but we're going to now. So I'm going to draw let's draw a little graphical representation of this. We have a circular one for the picture of the graph, but let's actually draw a sine wave. Okay, what's our dependent and independent variable here? There's nothing about time in this question, and time is your go-to for your independent, right? Time. We're not talking about time. We're actually, both of them are distance. Our independent down here is the distance traveled by the tire or by the spot of paint. This is the distance traveled. And the vertical is the height above the paint spot, height above the ground. So let's label those. Right, I've got distance traveled, independent, height above ground is my dependent. So let's start with our numbers for the height above the ground. What's the highest height this is going to reach? The highest it's going to get to is 80. Look at the tire up here, right? The highest height that this paint can get to when it's at the very top is 80. So I'm just going to put an 80 here. Remember, if the question doesn't ask you to graph it, you don't have to worry about graph paper or getting accurate intervals. This is just to help me figure it out. So the highest it's going to get to is 80. The lowest, the minimum, is 0. When it's on the ground, it's going to be 0. So I'm going to put a 40 in there just to give myself some scale. 60, 20. Okay. Now let's look at our independent, the distance traveled. I'm going to put one full cycle on here, and one full cycle is one full cycle. Remember, that's up here. We talked about that in gray. Is 251.3. 251.3 is one cycle. So let's say halfway is about there. Okay, now we'll put our tire on. So where does this all start? Do you remember? It starts when the tire drives through the paint, so it's at 0, 0. So it starts at the bottom, and one full cycle later, it's back at the bottom again. Our maximum would be at halfway, that's about here where I put the dot, and 80. That's our maximum. So my wave is looking like this. That's not great, I'm gonna fix that. All right, so there's a wave, and now what am I looking for again? I'm looking for this value here, 242.5, so that's gonna be about here somewhere. Now, up here, so if I wanted to, I could look at the graph and say, oh, I'm gonna estimate the height above the ground there. That's not the greatest way to do it, of course. I think there are some questions like that in your textbook where they just give you a graph and they want you to estimate the value, but we're going to do a better job than that. Remember, what we're looking for here is we're looking for the height of the tire when it has traveled 242.5 centimeters. So the best way to do this would be to have an equation to sub into. So let's come up with an equation. The equation, using the variables we have here, are height and distance. H at D is equal to, so I look at my graph here and I see that I can use cos. I could either use the first maximum, but since I have a minimum on my y-axis, I'm going to use cos, and I'm just going to make my A value negative. What is my A value? What is my amplitude? So that's a 40. It's the radius. The radius is the amplitude in any of these circular questions. You don't even have to really think about it. So we've got a negative 40, and I'm using cos. And now I need a K value. So K value goes in here. Now I know I'm going to have D. Well, let me just leave an X for a second there. X minus D, because my D value is going to be, that's going to be a 0, right? So I'm actually going to change that to the proper letter we're supposed to use as a D. I just didn't want to confuse you because this was a D as well, but I'll fix that. And then our C value goes on the outside. And what's the C value? What's the equation of the axis? That's a 40. So let me tidy all this up here. Okay. So we're going to have a plus 40 out here. Now I need the K value. The K value is equal to, oops, 360, because our parent cosine wave has a period of 360. We're going to divide that by our circumference. Remember, that's our rotation, that's our cycle, that's our period, 251.3. That gives us approximately 1.4. So 1.4 D. All right, so let me erase this K value. Now I have an equation. Now I can sub my value into the equation here. What I'm looking for is the height when my horizontal distance traveled is 242.5. Negative 40 cos Now in this bracket, I have to do 1.4 times 242.5 plus 40. So remember your order of operations here. The first thing you need to do on your calculator is the bracket. So this is first. Then once you get that number, you will find cos of that number. That's second. Then after that, you're going to multiply by negative 40. That's third. And the last thing you'll do, order of operations, bed mass, addition, subtraction is last, 4. So do all that on your calculator. Press pause so you have some time to do it, and then you'll see the answer. Okay, you got it? You get an answer? You should get about, let me go back to purple. You should get about 2.5, approximately 2.5. So what did we find? We found the height of the paint spot. It was only 2.5 centimeters above the ground, half a kilometer away. So I will write a sentence for that. Therefore, the paint spot is approximately 2.5 centimeters above the ground. That is a complicated, very complicated circular question because it has a lot of different pieces to it. When you get questions like this in your homework, they're definitely complex, so make sure to look up, watch this again to get some maybe hints about how to do these questions.